Good afternoon, ladies and gentlemen. It is an honor for me to speak in front of you. First of all, please allow me to introduce myself. My name is Darfian Ruswifaqa, a bachelor student from Mechanical Engineering Department, Universitas Indonesia. In this occasion, I would like to present my paper entitled Utilization of Raspberry Pi and Android as a basis for development of 1500cc four-wheeled vehicles fuel consumption, monitoring and driving behavior identification application through OBD-II port. This presentation will consist of four parts: introduction, supporting theories, research method, and discussion and conclusion. The background that leads me to this research is the high vehicle ownership growth rate in Indonesia that reached 10% on 2016 to 2018. This growth is also accompanied by a surge of increase in motor oil consumption, peaking at about 36.4 billion liters of oil. Low efficiency on fuel consumption is one of the reasons to blame, with the culprits of this inefficiency being improper driving behavior. Study shows that implementation of eco-driving will result in at least 7% and up to 40% fuel efficiency improvement. The problem is, it is not 100% effective as drivers rely on their personal judgment upon driving. However, there is an opportunity to solve this problem. Most modern automobiles have OBD2 system which could be utilized to acquire data from the car, such as for fuel consumption. This fact, combined with a huge potential on utilization of IoT, led to great opportunities to develop an application-based monitoring. This research used several supporting theories such as four-wheel vehicle fuel consumption, driving behavior, measurement system analysis, and mean absolute percentage error. According to Messager on 2015, automobiles' fuel consumption can be calculated using fuel flow and speed data, resulting in instantaneous fuel consumption. The fuel flow itself is a product of mass airflow times 3600 divided by the actual air-fuel ratio (AFRA) and fuel density (FD). In this research, the fuel density used is 737 gram per centimeter cubic. This research also uses fuel consumption calculation method from SAE J1082 standard to aid in calculating the fuel consumption of the full-to-full method used on the application verification. One of the main components in this research is driving behavior. Canali on 2002 said that driving behavior could be described as certain parameters such as accelerator and brake pedal pressure. Also, Nalin on 2014 stated that driving behavior could be categorized statistically using the said parameters. This research collects several data from the OBD2 port. It has PID number which is set according to standard. The acquired data are RPM, speed, MAF, and accelerator pedal position. This data is collected using ELM327 OBD2 scanner that is connected to a computer. The research flow in this paper starts from problem identification all the way until the research method could be determined. Then, an application for initial data inquiry is developed on collect data and identify the driving behavior parameter. After that, the final application is developed and a verification method is applied for the application. There are several parameters used in the initial data acquisition. Those parameters are used to assess the driving behavior obtained from the test. 7 drivers are educated on the test protocol and route, then they are asked to drive according to their judgment with the knowledge in mind. This protocol and route are used both in the initial data collection and final application verification. In the final application, the full-to-full method is used as a mean to verify the application. The procedure consists of filling up the fuel, resetting trip meter, conduct the test, and calculating the consumed fuel. The obtained data is perceived in two ways. The first and second formulas are used to calculate the fuel consumption from the OBD data. The result, along with the accelerator pedal position data, will serve as the basis for creation of driving behavior identification. The third and fourth formulas are used in the application verification process. Data from the second formula were compared to data from the third formula using the fourth formulas. This is the sample of the calculated data. The driving behavior identification process is done using accelerator pedal position and fuel consumption data obtained from the formula on the left slide. It is identified using measurement system analysis and histogram to easily recognize the reference points. The results are 3 drivers to conduct application verification process and 3 driving behavior class. The initial data acquisition resulted in the following histograms. Those histograms serve as a basis to determine the value of the reference points. This data is also used for the MSA method to determine 3 of 7 drivers for the application verification process. The result of the MSA is a combination of 3 drivers, A, D, and E. Those drivers are chosen from their combination fuel economy and accelerator pedal value. The percent EV value of under 10% shows that the data acquisition is precision enough. Percent AV and percent R&R shows little variation between each driver, which is a sign of good repeatability and reproducibility. Lastly, high percent PV value shows that each driver could differentiate between each driving behavior. The distribution histogram also serves to differentiate values between each driving behavior as shown on the table. The application verification process is done on 3 days with 3 sessions on each day. Each session consisted of 100 km of distance, with each session covering 300 km for total distance covered of 900 km for the whole experiment. The application verification data is obtained from the full-to-full method. It is used to determine how accurate the final application at displaying the data. The error figures are calculated from the OBD and full-to-full data using mean absolute percentage error formula. The final application has the ability to display the fuel consumption data and driving behavior analysis in real time. The workflow of the application starts from data acquisition from OBD-II port using Raspberry Pi, resulting in the car parameter data. This data is calculated by the Raspberry Pi and sent through Internet to the backend cloud. The backend cloud stores the data and sends it upon request from the Android application. Finally, the user can see the data at the screen of their phone. The conclusion on this research are the range of fuel efficiency obtained is in the range of 8.5 to 11.5 km per liter for eco, 4.8 to 8.5 for normal, and 0.4 to 5.9 for sports. The accelerator pedal position figures obtained is in the range of 6 to 12% for eco, 12 to 24 for normal, and 24 to 45% for sports. The error regarding the fuel consumption resulting from the application with the fuel consumption of the full-to-full method is average of 13.1% with a standard deviation of 4.5%. Then, finally, it is possible to develop an application for monitoring fuel consumption and driving behavior using the Python programming language for the Raspberry Pi, the Django framework for the backend cloud, and Android for data display application. This is the end of my presentation. Thank you very much for your kind attention. If you have any question, feel free to ask me. Thank you very much.